This session is a technical presentation aimed at solution architects and CIOs who are considering entitlement management within their organisations. I intend to give an overview of the Access Sentinel architecture and a brief introduction to XACML, and if there's any further interest we can easily arrange further discussions or further WebExes. Firstly, I should describe what Access Sentinel is. The Access Sentinel product is an entitlement management system for enterprise applications based on XACML. So firstly, I'd like to describe briefly what XACML is at a very high level. So XACML is the Extensible Access Control Markup Language. The standardized documents define two things principally. Firstly, a standardized language for expressing access control policy, and those policies are expressed as XACML documents, which are XML documents. And the XACML standards also define a reference architecture and protocols that allow access control decisions to be externalized from enterprise applications into a common service. There's a number of advantages in externalizing access control. Firstly, application development time is reduced because developers don't need to create an access control system for each new application that they develop. It's also possible to make changes to access control policy quickly and easily because the access control policy is consolidated in one place. It's not necessary to go back to each of the applications and recode them to conform to the new access control policy. And because the access control policy is consolidated into a common service, it's possible to achieve a unified view of access control policy across the entire organisation. This has an obvious benefit for auditing, since an auditor can simply go to the common service rather than having to go to each of the applications to work out who is allowed to do what to what resources. There are four principal components within the XACML architecture. The Policy Administration Point, or PAP, is the system component that stores the access control policies. These are the XACML policy documents, which are XML documents, and allows those documents to be maintained through their life cycle, to be created, modified and deleted. The Policy Information Point, or PIP, is the system component that acts as a source of attributes pertaining principally to users, but also about other objects within the system. The Policy Decision Point is the system component that actually makes access control decisions, whether an access by a user is to be permitted or denied. Upon receiving an authorisation request, the PDP will assess appropriate policies obtained from the Policy Administration Point and appropriate attributes from the Policy Information Point and achieve a decision, which it sends to the Policy Enforcement Point, which is the component that's actually embedded in the application and controls the access by the user, either allowing or disallowing access based on the decision returned by the PDP. Within the XACML standards, there is an XACML data flow model. This is a simplification of the model in the standards, but it captures the essential features. On the left-hand side, we have Policy Enforcement Point in an application server, and there may be many application servers. The Policy Enforcement Point doesn't make the decision about access, it defers the decision to the Policy Decision Point by sending an authorisation request. The Policy Decision Point in the middle obtains appropriate policies from the PAP and obtains appropriate information about the user from the PIP. Now this diagram misses a rather important detail. The PAP and the PIP are themselves application servers in their own right. Both the PAP and the PIP have their own sets of users. So in the case of the PAP, it's the policy administrators, the people who are modifying the XACML policies. In the case of the PIP, it's the attribute administrators, who are the people modifying the user's attributes, typically users' attributes, as well as attributes about other objects. Now these users, the policy administrators and the attribute administrators, need to be properly authenticated to the PAP and the PIP. Their actions on the PAP and the PIP also need to be properly authorised. So if we treat the PAP and the PIP as application servers in their own right and apply the XACML data flow model to them, what do we end up with? Well, it looks like this. And in fact, we could extend this diagram out infinitely on the right-hand side. However, in practice, you'll typically find the PIP is an LDAP directory. If you go to any large organisation, you'll typically find that they have an LDAP directory which has information about all their users, so attributes about all their users. So you'll find in practice in an XACML deployment that an existing LDAP directory will be used as the repository for the PIP. Now, LDAP directories can store XML documents, but only as blobs, either blobs of UTF-8 characters or blobs of octets. They can't actually understand the structure of those documents or do semantically meaningful comparisons of those documents or filter matching on those documents. So what you'll typically find is that for the policy administration point repository, a new relational database will be set up to hold the XACML policies. And that's because relational databases on the whole have reasonable support for doing semantically meaningful searches on the contents of XACML policy documents. Now, of course, a relational database and an LDAP directory both have their own store of user identities, they both have their own access controls, and they make their own authorization decisions. So what we have in practice is not an infinitely recursive deployment of XACML servers, but rather a situation as depicted here, where we have one level of dereferencing. So we have a PAP, which is effectively a relational database, and we have the PIP, which is effectively an LDAP directory. But what we do have is, in fact, three access control schemes in force. We've got the XACML policies that are stored in the PAP, which control access by the application users out in the network. But we also have access control lists stored in the policy administration point to control access by the policy administrators. And we have access control lists stored in the PIP to control access by the attribute administrators. Now, if I take a step back and have a look at how ViewDS fits into this picture, the ViewDS discovery server is an LDAP conformant directory server, so it can quite happily be deployed as the repository for the PIP. But also, the ViewDS has native support for XML. It's possible to upload the XML schema definitions for XACML policy documents so that it then understands those documents and it can do semantically meaningful filter matching and component matching of those documents. So with ViewDS Discovery Server, we can quite happily put both the XACML policies and the user attributes in the one repository, in effect combining the PAP and the PIP into a single component. But what we do in addition to that is take the next step and combine the policy decision point into that same single component. So what we now have is an enhanced ViewDS Discovery Server that, in addition to being a directory server, also supports an external PDP interface that external applications, or that PEPs in external applications, can use to obtain authorization decisions. There's a number of advantages to combining the PDP, the PAP and the PIP into a single system component. Firstly, there's a reduction in administrative overhead because there's only one component to deploy and administer instead of three or possibly more. We have another advantage in that the PDP is accessing policies and attributes directly because they're part of the same component without having to go through an additional layer of authentication or authorization or integrity protection or confidentiality protection. But most important, we can now, with this architecture, fully realise the goal of unified authorization policy that applies to everything within the organisation, including the authorization system itself. And that's because the PDP in the ViewDS Access Sentinel server is the same PDP that's used by the PEPs in the application servers, and it's the same PDP that's used by the PEP that controls access by the policy and attribute administrators accessing the content within the ViewDS Access Sentinel server. So rather than needing three access control schemes to set up the authorization system, we actually only need one. One collection of XACML policies covers access to everything, including data that's pertinent to the access control system itself. By building the Access Sentinel server basically on top of the ViewDS Discovery Server, we get a number of capabilities for free. One of the interesting things that the directory can already do is replicate and distribute its information, its collections of attributes. So it's very simple for us to set up multiple Access Sentinel servers as required throughout an enterprise network. We expect that the amount of traffic between a PEP in an application and the PDP in an Access Sentinel server is going to be much greater than the amount of traffic that a collection of Access Sentinel servers would generate in simply keeping themselves up to date with respect to the user attributes and with respect to the XACML policies. So it makes a lot of sense to simply put an Access Sentinel server close to each application that needs to be served. We get an improvement in performance then, because rather than each of the applications having to go over the network to a central site to obtain a decision from a PDP, they could simply talk to an Access Sentinel server that's located on the same machine or in the same LAN. We can also deploy multiple servers for other reasons, such as to provide high availability or load balancing. If one Access Sentinel server goes down, there's another one nearby that can take over the load. or if there's an application that's particularly demanding and needs to make a large number of authorisation decisions or to obtain a large number of authorisation decisions, then we can simply deploy multiple Access Sentinel servers close to that application. The directory distribution mechanisms also provide some interesting capabilities, such as the ability to partition the collection of policies and partition the collection of user attributes. In an organisation, for example, that runs perhaps a top secret network and a separate unrestricted network, they could have a collection of Access Sentinel servers within the top secret network that contains all of the policies pertinent to access within that network and all of the user attribute data that's pertinent to the users of that network, and separately within the less restricted network provide a separate set of Access Sentinel servers with the policies that apply to access within that network and the set of user attributes for users within that network. In summary, by combining the PDP, the PAP and the PIP functionality into a single system component, as we have in Access Sentinel, we have a component which is easier to deploy and administer because we have fewer discrete components, one where we might otherwise have 3 or more. We achieve higher levels of performance because we've eliminated a large amount of external messaging and made it internal function calls. And we can also achieve a fully unified enterprise view of authorisation policy, where the policy applies not only to access to applications within the enterprise, but also applies to access to the authorisation system's data itself. And we obtain a number of capabilities essentially for free, such as fault tolerance, load balancing and locality of access through the existing directory capabilities of the ViewDS directory server. For further information, please refer to the ViewDS website. We are also able to set up individual discussions or WebEx presentations to go into more detail about ViewDS Access Sentinel.